Okay, in this video we'll be talking more about differentiation, and specifically we'll be looking at 25C and the derivative function. Okay, this should actually say derivative function here. Okay, now so our objectives for this video are to find the derivative function and define it using limits. Okay, so what is a derivative function? That's a new word there for us, and we'll talk more about what that means. Okay, we'll also be able to find derivatives of functions using the derivative definition. That should say definition. Okay, so let's get into it. Alright, what is the derivative function? Alright, if you recall, we had some function, and what we did in the last video was we were trying to find the slope of the tangent line at some given value of the function, right? But these tangent lines don't stay the same on this curve, right? The tangent line over here is this line. It's pointing straight down, but the tangent line over here is pointing straight across, and the tangent line over here is pointing up. Okay, it's going very, very steeply in an upward direction as I read from left to right. Okay, so the slope of the tangent changes as we move across the curve. Okay, along the curve. As I move this way, you're going to see that it's very negative. It becomes, the slope becomes, right here, the slope was probably like m equals minus some really large number. Okay, maybe at this point it's like minus 10 or something. Okay, over here at this point, maybe m is equal to 10. Right here, maybe m is equal to, I don't know, maybe minus 2, okay? And here maybe m is 2. Okay, looks like m right here, the slope of this line would be 0. So you can see that the value changes as I move across this function. Okay, and we can actually take these numbers, and if you were to plot this on a graph, you would see that they actually form they can form a function. Okay, and that's what we're going to try to do. We're going to try to find this function that models the slopes of these tangent lines. Okay, and the function is going to be really useful for us, because then we could find the slope at any point, right? So we will call this function the derivative function. Okay, it's called the derivative function, and the way we notate this is, let's say f of x is something, okay, then the derivative is f, and there's a little apostrophe here. We're going to write it, and it's going to look like this. Okay, so f apostrophe x, we actually call that prime. Okay, this apostrophe is called prime. In some, I think if you're from a European country or British or Australian background, they call this a dash. Okay, they call it a dash, but in the US you'll hear this commonly referred to as prime. So this is f prime of x. Okay, and that's going to be some function of x. Okay, so let me just tell you how to say that. That's f prime of x. Okay, that's how you'd read this. And this is the notation that we'll use to denote the derivative function. Okay, so remember that the derivative is it tells me the slope of this of the tangents at any point on my f of x curve. Okay, so there's a lot of moving parts here. Make sure that you are understanding what that means. Okay, now if we look back to number 3 in section 25b of our textbook, this was from the previous section. If you did number 3 here, you should have found that when f of x was x squared, okay, when f of x was x squared, the gradient, if you filled this table out and looked at the numbers, you would have seen that the gradient of the tangent, okay, the gradient of the tangent for this function, the gradient here, whoops, well, that's way off. The gradient here, and the gradient here, and the gradient here. Oops. Gradient here. Okay. All of those gradients would actually be double the x value right there. Okay. So this would actually be 2. This was 4. This was 6, and this was 8. Okay. This is what you would have found. Double this, the x-coordinate. When I doubled it, that was the slope of the tangent line. Okay, so that's kind of an interesting connection that you should have found here. And so we could actually define this in terms of the x value. Okay, how does this change based on my x? Well, this is really just double the x. So we could have said f prime of x is really double whatever the x value is. Okay, so you can see here there's a connection. F of x is x squared. F prime of x is 2x. Okay, we'll be looking more at the rules and some of the patterns that you'll see here in the next video or the next section. But for now, we will be using another method to get from here to here. How do I get from f of x to get to f prime of x? Okay, so how am I going to find this? If I'm f prime of x, if I'm given f of x, I'm going to be using the limit definition. Okay, the limits that we've been talking about. Okay, we're going to use this idea of limits to figure out this derivative function. And it turns out, okay, that this formula that we used before in the previous section to find the gradient of the tangent actually will result in the derivative function. Notice here that the only difference here is that I'm not using a. Okay, I'm not using a single number. I'm using a variable. Okay, so I'm making it more general. So whereas before I was looking for f prime of a. Okay, in section B I was looking at section B, 25b we talked about f prime of a. But now we're going to be, instead of looking at for the slope of the tangent line at a single point, well, we're going to replace that with x and say, well, what is the function? What is that in terms of x? Okay, and so this formula here is very, very important. You will need to know this, and you will need to know this whether you go to SL or HL next year. Okay, so f prime of x is the limit as h approaches 0. Remember, that's how we read it. The limit as h approaches 0 of f of x plus h minus f of x all over h. And this is really just the slope of the secant line, and we're making this line move closer and closer to the desired point of tangency that we're looking for. Okay, and this process of getting f prime of x. Okay, so if I have f of x and I look and I'm trying to get to f prime of x, we say that is differentiation. Okay, so there's a lot of vocabulary here. Differentiation is the process of finding the derivative function. We can actually instead of calling it the derivative function, we can shorten this and we just can call it the derivative. Okay, so whereas we have f of x, we call it the derivative. F prime of x is the derivative. Okay. And specifically, if we use this method of using the limit, we call it differentiation from first principles or using the limit definition. Okay, so this right here is very specific. This is, by using this formula, we are differentiating using first principles. Okay, this part here, we will be we can still differentiate not using this, okay, without using this. We can still find f prime of x without using this, but we'll look at those rules next in the next video. Okay. All right, so find the derivative function of f of x equals x squared. Now, let's see. How do we find this? And we're going to do this using first principles here, okay? Let me just do this in this format here. Okay, so find the derivative of f of x equals x squared. Now, The only way we know how to do this right now is using first principles. So we're going to use first principles here. F prime of x equals, and here's our definition, the limit as h approaches 0 of f of x plus h minus f of x. You should be very familiar with this if you did the last video or the last section. Okay, now I need to figure out what this is, and then I can just substitute, right, and solve the limit. So what is f of x plus h? Okay, f of x plus h is, all I need to do is put in an x plus h here and an x plus h here, so I'd get x plus h squared, and f of x is just x squared. Okay, so this is the limit as h approaches 0, and I saw many of you doing this in class. Please make sure you write the limit before you solve it. Okay, so if I haven't solved it and I'm just substituting, make sure you write this part in, because it's important to communicate that to the reader. Okay, so here I'm going to be substituting here f of x plus h squared minus x squared all over h. Okay, I'm still going to be simplifying this because I can't solve the limit. I can't substitute in 0 yet. So I'm going to keep writing this part here, and this becomes now x squared plus 2xh plus h squared, right? This squared becomes this minus x squared all over h. Okay, and so now this cancels and this cancels, so I'm left with this. I can factor out an h there. Okay, so this should be very easy now. I can factor out an h from each of these terms, so I get 2x plus h all over h. This cancels, so now I can solve the limit. So now I can say that is 2x plus 0. I can substitute, and so that's just 2x. Okay, so there, I found f prime of x. So f prime of x is 2x when f of x is x squared. Okay? All right. Let's try another problem. Now this problem says find f prime of x given f of x equals x to the fourth. Oof. Okay. I'm going to let you read this in the textbook. Okay. This is pretty much the same process. Okay. And I'm gonna be looking at more importantly how to find f prime of -1 and then interpreting that answer. Okay. But I'll just give this part to you, and you can look at this in your book. But f prime of x basically will turn out to be, well, it's the same process. Let me just write this part out here. Okay, the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, still the same slope formula, and I'm just making it become the slope of the tangent by using this limit. Okay, if I do the math here, this becomes f prime of x, and I actually end up with 4x cubed. Okay, and I'm just going to give that to you. You verify this. Okay, and what I'm going to do now is part B, which says, okay, let me just write this part over here. Find f prime of -1 and interpret this answer. So let's say we've gotten this. Okay, what does f prime of -1 equal? Well, that's just 4 to the times -1 cubed. Okay, that cube, that's still -1, so that's -4. Okay, so now what does this mean? What does that tell me? Well, that really is the slope. Okay, that's the slope of the tangent, right? Also known as the gradient of the tangent at the tangent line to the curve f of x equals x to the 4th power. Okay, and this is the slope of the tangent line to this curve when x is -1. Okay, so let's draw a picture of this. What does that look like? Okay, if I were to sketch very quickly what x to the 4th looks like, it would look something like this. Okay, this would be y equals x to the 4th, or f of x equals that. Okay, where this is y and this is x. And at the point -1, okay, This is not terribly drawn to scale, so let me just terribly well drawn to scale, I should say. So this is the point that I'm interested in, and there's the tangent line that I'm interested in. Okay, and so it's saying the slope of this, okay, let me change my color here, the slope of this line is -4. Okay, and this value is actually the same as f prime of -1. Okay, so that's very nice, because the derivative will tell me the slope of the tangent line, of this tangent line, at any given value of x, and in this case the value of x is -1. So that's my slope. Okay, so this is very, very useful. It has a lot of applications. It might not seem very important right now, but it is important. Okay, and there are many different applications of this in math and in business and engineering and physics and many other subjects. Okay, so let me go back to my presentation here. Okay, so here are the key words: gradient and slope function, the derivative function. Okay, remember that these two are the same. Okay, these two are the same. They mean the same thing. This is just f prime of x, and this is the same thing. They both have the same function. The differentiation is the process of finding the derivative, and more specifically, if we differentiate by using first principles or the idea of a limit, then we are using the definition f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay? Alright, so that's it for this video. Please make sure to write down any questions that you have and ask me in class. Alright, thanks for watching.